Okay, so we can say that the magnitude of the total flux is approximately equal to the sum of all the contributions, right? Okay? And that approaches the integral over the surface of the magnitude of the electric field times the area, right? Okay? Well, what's that integral? What can you tell me about the magnitude of the electric field?
It's a AQ.
Oh,
Okay? Right?
Yeah.
Over what?
I guess we could say R squared.
should be R squared.
Now, what's the radius of the sphere? I think I called it A, didn't I?
It doesn't say.
Let's see.
You didn't tell us.
No, on the first
Oh, I
one.
said any sphere, right?
Yeah. So,
Okay, I'm going to say A because I don't want to use R because R is going to be a variable of integration very soon. Okay?
Alright.
Okay? So let's assume retroactively sphere radius A. I could have used R, but R is a bad variable to use because, again, we use it in integration. Okay? So you'll very frequently see this. I'm pretty sure your text tends to use A. Sometimes a capital R. Okay? Okay, well, what's that? Any constants in there? You can factor out?
Okay.
And A squared.
Okay. Is K constant?
Yeah.
Is 2 constant?
Yeah.
A constant? Oh, gee. So that means that we got K magnitude of Q over A squared times the integral over the sphere of the surface area dA, right? And what's that?
I mean, that's the area.
You just get the area.
Well, what's the surface area of a sphere? If you can't tell me, I'm going to make you get it by integration.
4 pi A squared.
Okay, you saved yourselves. Okay. You should always know how to integrate to find that. There are other proofs. Knowing the calculus, you do the integral's the easiest of the proofs if you don't want to get into definition of steradians and stuff like that. Okay? The geometric proof is much tougher. But, yeah, it can be. Okay, so that's 4 pi K magnitude of Q, right? Okay? Now, that's the magnitude of the flux. Clearly, if Q is negative, the flux is going to be negative, and if Q is positive, the flux is going to be positive, right? Because if Q is positive, the field in the outward normal, which is the one you use here, and I've implicitly assumed that you know that, and you're supposed to, okay? The outward normal, outward unit normal, is parallel to E if Q is positive, giving you a positive flux. And if Q is negative, then the field is inward, the normal is outward, and the flux is negative, right? So, whether the charge is positive or negative, you get this. Easily verified.